Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 2439 that says minimize maximum of array. This question is very much interesting guys, and here in this video we will discuss different approaches to solve this question. We will first make some of the observations by the question definition of this question definition, and then based on the observation we will try to solve this question, and then we will try to optimize our solution, right? So as we discuss the intuition part first and then the approach, so we will follow the same thing in this video, but we will discuss multiple approaches, correct? The one approach we have selected, then we will try to optimize that approach. So yeah guys, this video is going to be interesting, so stick till the end and make sure you like this video and subscribe to our channel. Now going towards the question understanding part, so here you are given the zero index integer array nums, and it only contains positive integers that can be 0 and greater than greater than equal to 0. All the integers would be okay, and further you are asked to perform the operation in order to achieve the answer. See, you have to perform this operation. What you can do is you can select any index I starting from 1 up till n, any index from 1 to n, and you will decrease that element at that index I by 1, that is -1, and increment the previous index by 1. Okay, and you can perform this operation any number of time. Now what you need to achieve by performing this operation, you need to return the minimum possible value of maximum integer. Okay, so let's say here in this example you are given 3, 7, 1 and 6. What is the maximum integer? 7 is the maximum integer. But by performing these operations any number of times, you will try to reduce the maximum integer and try to minimize it. Okay, clear it is? So now if you take a look at this example given 3, 7, 1, 6, and let me also write the indices. So guys, as you can see clearly that at the integer at index 1 is the maximum integer. So let's try to minimize it. So here I am performing the first operation. Okay, so here 3 will become 4, 7 will become 6, 1 and 6. See, this is +1 and this is -1 because I is this is our I. Okay, index 1 is our I, so we perform -1 at the index I and increment the previous index. Got it? Now performing the second operation. So as you guys can see that here we have 6 as a maximum integer. So let's try to reduce that 6. So for that our previous integer will become 5 and this will be 5, 1 and 6. Now 6 is also there, 1, 6 is also there. Now let's try to minimize that. So in the third operation what we will do is we would simply increment this 1 to 2 and reduce 6 to 5. Okay, now guys, as you can see that this 5 can be reduced. So if you perform the fourth operation, then you can get something like this 3 and 4, but this 5 can never be reduced. Why? See, if you try to reduce this 5, then ultimately this will become 6, right? 6, 4, 3, 4. Now that is not optimal solution, because 6 here is maximum and in the previous step you were having 5 is the maximum integer, correct? So this is not correct answer, and you can never reduce this any number that is present at index 0 can never be reduced, never, right? Because our decrement operation will perform on nums of I, where I is an index from 1 to n. So you can never decrement any number present at index 0. Clear? So this is one observation. Okay, so guys, in this example if 5 is the maximum value that you can achieve, and that is the minimum possible from this for this nums array. Okay, now here in the second example, so guys, here what you can see the 10 and the maximum number present here is 10, and 10 is present at what index? 10 is present at index 0, and as I have already shown you that any number present at index 0 can never be reduced. This number at index 0 can never be reduced. So yeah, we written 10 as our answer because that was the maximum integer and that was present at index 0. And since we can never perform decrement operation at index 0, so that's the case, that's why we can never decrement this 10 value. Okay, clear till here? So guys, till now what we have observed is any index whose at index 0, any number at present at index 0 can never be decremented. That nums of index 0 can never, and never means never, be decreased. Okay, now guys, one another thing So okay, so let's say you are trying to perform brute force approach. So in a brute force approach, what you will do is, so you, any nums array you have like this, like something like 1, 3, 5 and 7, what you will do is you try to decrement the maximum integer. So here the maximum integer is in index 3, so you try to decrement it, so it will be something like this, 6 6. Okay, now the maximum integer is 6 again, but you cannot decrement this. Okay, means if you decrement this, then this will increment. So let's say you select this index 2, then you will get 1, 4, 5, 6, then this is the maximum, right? Okay, so let's say you do something like this, 1, 4, 6, and here you convert this to 5, and in the next step this is the maximum. Then what you can do is 1, 5, and for this what you can do, reduce to 5 and 5. Now you target this index, it will become 2, 4, 5, 5. Again you target this index, 3, 3, 5, 5. Okay, then you target this index, then it will get 3, 4, 4, 5. Okay, then you target this index, then it will become 3, 4, 5, 5. Okay, then again you target this index, means after this no more optimization is possible, whatever you will do, and you will get 5 as our answer, right? Here 5 as our answer. So what you can see, guys, that see there are means you are performing this step multiple number of times to reduce any integer. So if you will keep on doing this up till what would be the terminating condition? So here the terminating condition, so for this brute force approach, what would be terminating condition? So whenever the maximum integer increases, okay, that would be the terminating condition. So after this case, so here we have reached 3, 4, 5, 5. So after this case, if you will try to decrement this, then also you will get 3, 5, 4, 5. Okay, then if again you can try to decrement this, you will get 4, 4, 4, 5. Then you can try to decrement this, 4, 4, 5, 4. Again you can try to decrement this, then you will get 4, 4, 4, 5, 4, 4, and you can try to decrement this, then you will get 5, 4, 4, 4. So after this, guys, as you can see, the maximum integer was present here. Maximum integer was present at the 0th index. So this is one terminating condition. So when a maximum integer increase or the maximum integer is present at 0th index. So in some of the example you will observe this, and while in other cases you will observe this. So if any of this condition may hit, then that will be the terminating condition for a brute force approach. But this is very much inefficient approach, as you can see, because for this brute force approach the time complexity would be what? See, here you are trying to minimize the maximum integer. So the maximum possible integer is what? 10 to the power 9. Okay, correct. And what is the minimum 1? So this is the minimum. Let's say this is the minimum value of the nums array, and this is the maximum value of the nums array, right? You are giving something like this. So if you try to 2 plus 1 and minus 1 this operation, then how many times you have to do? At least you have to do 10 to the power 9 by 2 number of times. Okay, got it. So this many times you have to do this operation. Now let's say if you have something like this, 1 comma 10 to the power 9 comma 1 comma 10 to the power 9, and at a time you do one operation, right? So this will take what? 10 to the power 9 by 2, plus this will take what? 10 to the power 9 by 2. Okay, this many operation. So if you have something like this, then this will take this would take what? 10 to the power 5 by 2, because this is the maximum length of array. So this much time complexity it will take, correct? So this will shortly give you TLE. Okay, yeah, the space complexity for the solution is big of 1. We are not storing anything, but this was the brute force approach, and as you can see that you will never get a better answer by this approach. This is very inefficient approach. Okay, now what another thing you can do is, see, for any given array like 1, 3, 5, 7, what is fixed? The lower limit is fixed. This is the lower limit. Any number present at index 0, that is nums of 0, this is the lower limit. And what is the higher limit? it is the maximum integer that is present of the complete nums of array. So here it is 7, here this is 1 and this is 7. So this is the lower limit and this is the higher limit, and your answer will always rise between these. Your answer will always lies between the lower and the higher limit. Okay, correct, clear till here? Now, so let's say your lower limit here is 7, so your answer can be 2, 3, 4, 5, 6 and 7. Your answer can be anywhere from this. Now whenever you have some range of answers, okay, you have some range of answers, this is the range of answer, and you need to find what is the optimal possible answer from the given range. You need to find optimal possible or valid answer. Then what you can do is you can do binary search, right? Binary search, not simple binary search, but binary search on answer. You can use this concept because you are given the range of answer and you need to find the optimal possible answer from the given range, and at that point you can apply binary search on answer. Clear? So this is the intuition of binary search on answer, that you have the lower limit fixed, upper limit fixed, and you need to find range. So why binary search will works? So because you will pick some of the middle element. If your answer is valid, this middle element answer is valid, then what you can do, you can move towards the left. If this is not valid, move towards the right. So you will make this type of jumps, correct? This type of jumps. So instead of checking for all the elements from 1 to 7, you will make jumps and select few of the elements, and based on that you will either move towards the left or to move towards the right. See why this will work here. So for a given this 1, 3, 5, 7, so if you try to check if 4 is a valid possible answer, so what is valid possible answer here? So if you try to perform some of the operation in such a way that maximum integer 4 is achievable. So if you try to perform operation, so perform operation n number of times such that maximum integer in array is mid. So if you somehow find that mid, so let's say the mid is 4, and if this is achievable, then you will move towards the left, right? You will move towards the left and find better answer, right? And if this is not achievable, then this all the numbers will be discarded and our new range will be 5, 6 and 7. This would be our new range. So guys, in this type of situation where we check for one value and then we check and then we make a decision to move left or right, so in this type of situation we can use binary search on answer concept. Okay, clear till here? Clear the intuition part? Now now to check, now we need to somehow think of this valid answer, that how we can find the valid answer. So this is where we write the helper function for the binary search. Okay, now before that let me show you one simple observation. So for any nums array you are given like 1, 3, 5 and 7, what you are simply doing is you are simply doing -1 for ith index and +1 for I plus 1 index. Okay, you are doing this operation, right? So what thing is not changing? See, the numbers are changing, like you will get like 2, 3, 4, 5, 5, you will get some number like this. But what is that one thing that is not changing? The one thing that is not changing, that is the total sum of array. So the total sum of complete array is not changing, right? If you do 7 plus 5 plus 3 plus 1, that would be same at any stage, right? 5 plus 5 plus 4 plus 3, because overall you are doing nothing. Overall you are not adding, you are simply adding 0, right? -1 plus 1 simply adds to 0. So you are not changing the total sum of the array. Okay, clear till here? So that means, let's say you have 4 integers, let's say num1, num2, num3, num4. Okay, and let's say you have some integer, let's say you are doing binary search and answer, and let's say x is some mid, so x plus x plus x plus x. So if you try to add this all numbers, and similarly you do for the x this many times, 4 times, then this value should be less than equal to this. Okay, for a x to be valid. So what is x here? X is the mid, that is minimum, that is the maximum integer assumed. That is the maximum integer that you have assumed from the range 1 to 7. Okay, so this is the thing. So now if sum of the integers is less than equal to x plus x plus x plus x, then we can say x is valid. Okay, if you have so you might be confused at how we can directly say x is valid. because let's say we have something like this: 1, 3, 5 and 7. What is the total sum? 7 plus 5, 12 plus 3, 15 plus 1, 16. And let's say let's assume x is equals to 4. Okay, now 4 into 4, that is what? 16. Okay, so you can say 4 is one valid answer. Now if you check for x equal to 3, now 3 how many times? 4 times, it's 12. So 3 can never be answer, never be our answer, right? 3 can never be our answer. Okay, so any integer that is greater than equal to 4 can be our answer. Okay, clear till here? Now what another thing that you have to identify here is, let's say you have something like this: 7, not 7, you have something like this: 5, 3, 1, 7. Okay, so you have some integer like this. So here also answer is 16, correct? Now, but if you take a look for x equal to 4, then also you will get 4 plus 4 equal to 16. But 4 isn't possible, right? You can clearly see that in the number at index 0 is 5. So 4 can never be possible. Okay, this 4 is never possible, your answer. So for this situation, so this is one valid logic. See, this is one valid logic, but you have to check for all the paths. So that means what you have to check. So because this type of situation can also arise where the overall sum is 16, and for that 4 is possible value, but since the first number is itself 5, then you will never get 4 as our answer. So to handle this situation, what you will do is, so instead of doing n1 plus n2 plus n3 plus n4, what you will do, we will check n1. If n1 is less than equal to x, then n1 plus n2 is less than equal to x plus x. n1 plus n2 plus n3 is less than equal to x plus x plus x, and you will check n1 plus n2 plus n3 plus n4 if this is also equal to x plus x plus x plus x. Okay, if all this condition is satisfied, then only we can say that our answer is x. Okay, clear till here? All the condition has to be satisfied for the first number that is present at index 0, then for the first two numbers, then the first three numbers, and then for the n numbers. Okay, clear till here? So if you achieve this condition for all this prefix sum for the first number, for the first two, first three, and first all the four numbers, then only you can say x is a valid answer. Okay, clear till here? Now we will use the same concept in our binary search approach to solve this question. See, okay, because what we have for the binary search, we were only thinking of how to check whether some x is a valid or not. So for that first intuition, what we took is -1 plus 1 doesn't change the value of the array. Second thing what we took is we first observe that, so for any valid x, the overall sum of this n1 plus n2 plus n3 plus n4 should be less than equal to all these numbers, correct? Sum of the x 4 times if there are 4 integers in the array. Now the second thing what we observed is, let's say 4 is a valid possible answer for some type of array, but if we just simply change the position of the integers, then in that case 4 can be invalid because the 0th index element can never be decremented. So here 5 is the answer. So to handle this type of situation, we have to check this condition at every stage, for one integer, for first two numbers, for first three numbers, and for n numbers, correct? Clear till here? Now using this only we will code our solution. So let me show you the code here. The code is pretty much simple. So this is pretty much the binary search code snippet that I have used. So here I have taken the low as the nums of 0 because that is the lowest value possible, and high I find by the maximum value from this nums array. Okay, and also initially took answer as the high. Okay, clear till here? Now afterwards, this is the fundamental binary search rule while low is less than equal to high. Int mid is this is how I calculated the mid. Okay, and then I call this function minimum possible. So this is what I check, that if this is the mid, can mid be the minimum possible from this nums array? Okay, here we are trying to check whether this x is the minimum possible value from this nums array. For that I took the prefix sum, and for each iteration I check if prefix sum is greater than x into I plus 1, that is condition. So guys, that we have discussed that prefix sum should be less than equal to n time into x, n into x. Okay, so if it is greater than, prefix sum is greater than n into x, then at that point what we will do, we will simply return false. Okay, because this condition has to be satisfied, and this is not satisfied, then we will return false, else we will return true at our end. So this is the fundamental binary search while loop, and using this while loop we are calculating the mid, and we are checking if the mid is possible, and whenever the mid is possible we'll move towards the left. So let's say you have something like this. Let's say for 6 is possible, then we move towards the left, because we won't have, which we check for greater mid, so we move towards the left. And if at some point let's say you are checking for 3 and that is not possible, then we won't check for 2 and 1, we move towards the right. So this is not simply moving left, and this is moving right. This is left and this is right. Okay, so yeah, this is how we will use binary search to get our answer. Now the time and space complexity for this approach is, so time complexity is what? See, this complete loop will take n time complexity, where n is the length of this num set is n, and how many times you are performing this loop. You are performing this loop under this while loop, and this while loop will take log of this range, log of high minus low, this many times. This while loop will be iterating. So yeah, this would be the time complexity, and the space complexity here we are nothing storing, so it would be big of 1. Now can we perform anything better than this? Can we perform anything better than this? Yeah. So guys, let me show you that also. So here what you are doing, n1 plus n2 plus n3 plus n4, you are doing this, and you are checking if it is less than equal to 4 times into x. Okay, so now here x, what you are doing, we are checking for different values of x. What you can do alternately is, you can get x for all the n's. So if you divide this by 4, then you can get what? You can get the answer. Okay, so what you can do is, so guys, if you do n1 by 1, then n1 plus n2 by 2, n1 plus n2 plus n3 by 3, and n1 plus n2 plus n3 plus n4 by 4. Okay, if you can do this, if you perform this, then you will get some answer here. You will get some, let's say you will get some x1 here, x2 here, x3 here, and x4 here. Okay, so and what would be our answer? Our answer would be nothing but a maximum of x1, x2, x3, x4. Okay, clear? Our answer would be nothing but a maximum of this number, right? This was the thing what we are doing here. n1 is less than equal to 1 times x, n1 plus s2 should be less than equal to twice of x. So we are simply dividing this. So, and if you divide this, then you will get some number x1, either x2, x3, and x4, and the maximum of all this number would be our answer. Correct? This is what we are checking. So initially what we were checking, we were taking some x, we were taking some x dash, and this x1, and what we were checking is x1 is greater than equal to x dash, x2 is greater than equal to x dash, x3 is greater than equal to x dash, and x4 is greater than equal to x dash. So for this x dash of the binary search, we were doing this, we were simply checking this. Now what you can do is, if you take the maximum of this, then that would be nothing but x dash. That is the best possible answer. Okay, clear till here? So whatever we are doing in the binary search approach, that same thing we are doing here, but instead of checking for different x value, what we are doing, we are simply dividing and finding the answer. Correct? So that was what we are doing in the binary search in this for loop, right? So yeah, we simply we are simply doing sum. We are simply taking prefix sum divided by I plus 1. So initially we are doing what here you are doing, this prefix sum is less than equal to n into x. What is n? N is nothing but I plus 1. See, index, and for each index we are checking that. Now instead, if you move towards the bottom denominator, you will get the value of x. Okay, but the thing here is, you have to take the CL value. This is what CL value. You have to take CL value of this division. Now to take the CL value, you need double in one, either numerator or denominator. But if you want to find the CL value for the integer, what is the formula? The formula is prefix sum plus n minus 1 divided by n. So guys, this is the formula if you want to find CL for an integer. So here what our formula would be reduced to, what is n? N is I plus 1 divided by I plus 1. So this minus 1 plus 1 will be cancelled out and you will get prefix sum of r plus I divided by I plus 1. This is the formula for the seal, right? And we will check that for each iteration, like from I is equal to 0 up till n minus 1. Okay, clear till here, and we will take the maximum possible from all these possible x. We will take the maximum and that would be our answer. So yeah, understood this approach. Now talking about the time and space complexity, the time complexity for this approach would be big O of n, as we are traversing for n elements, and space complexity would be big O of 1. So from this we reduce our time complexity to a much lower big O of n. So yeah guys, I hope you guys understood the approach. In this question we have discussed the 3 different approaches from the intuition part. So yeah guys, that's all for this video. Make sure to like this video and subscribe to our channel, and if you guys have still any doubts, then do let me in the comment section. So yeah, thank you.